All right, coming at you today with a math lesson building on our fraction skills. We've done adding, we've done subtracting, multiplying, and so that leaves us with division. So we're going to look at dividing all sorts of fractions, and I'm going to start by going over some key ideas, just like I did for multiplying fractions. So some key ideas here, super similar to multiplying fractions. Number one, you don't need common denominators when you divide fractions. So you could do that. It'd be a giant waste of time, and it would make your fractions much bigger than necessary. So do not waste your time finding common denominators if you are dividing fractions. The second bit of information is similar to multiplying. You can't divide with mixed numbers. You have to make them improper first. And the real big reason for that is when you divide fractions, you don't actually divide at all. You're going to be multiplying. And so because you are multiplying, that's why everything I said for multiplication is relevant for division. So yeah, when you divide fractions, there isn't really any division. Instead, the way that you divide a fraction is you multiply the first fraction in the division problem by the reciprocal of the second fraction. Now, reciprocal sounds like a fancy word. That's right here. But all reciprocal means is the inverse of a fraction. So for example, if I had 1/3, the reciprocal of 1/3, you flip it, is 3/1. If I had, let's see here, 6/7, the reciprocal is 7/6, and so on and so forth. So to divide fractions, the key is in this statement right here. You actually, instead of doing any division, you're going to multiply. So it's going to be yesterday's lesson. And you multiply by the inverse or the reciprocal, it's a fancy word, of the second fraction in the division problem. And lastly, some people teach this by saying, when you divide fractions, keep, change, flip. All that means is keep the first fraction in the division problem the same as it was, change the multiplication, change the division to multiplication, and flip the second fraction. Flip meaning find the inverse of the second fraction. And so let's look at that in practice. First example for today, we've got 3/4 divided by 5/12. Well, instantly you see division, and you should say, nope, there's no dividing fractions. I need to multiply by the reciprocal. So I'm going to multiply, and then by the reciprocal. The second fraction is the one that's going to get changed, and we're just going to flip it. We're going to find its inverse. 5/12 is 12/5. And the first fraction just stays the same. So if I was saying keep, the first fractions keep it, change the division to multiplication, flip the second fraction. I don't really like saying this. It's better to use the right math words, I feel. But if keep, change, flip helps you remember it, use it. But what are you really doing? You're multiplying by the reciprocal. And so now it's yesterday's lesson all over again. Top times top, bottom times bottom. So numerator times numerator. 3 times 12 is 36. 4 times 5 is 20. And since this is an improper fraction, we're going to simplify it and put it as a mixed number. 20 can go into 36 one time with 16 left over. And then 16/20, the fraction part of this, can be simplified if you divide both of these numbers by 4. You'll have a simplified fraction. So 16 divided by 4 is 4, and 20 divided by 4 is 5. So your best possible answer to this division problem is 1 4/5. 3/4 divided by 5/12 is 1 4/5. Another example, we're dividing a fraction by a whole number. Nothing changes. We're still going to use the same thing that we said. We're going to multiply, so change it to multiplication, keep the first fraction the same, and we're going to flip the second fraction. Now, I know it's a whole number, but a whole number can be written as a fraction by writing it over 1. Any whole number, if you write it over 1, that's its fraction equivalent. So 2 is the same as 2 over 1. And so the inverse, the reciprocal of 2 is 1/2. I'm flipping the fraction. And now this is fairly straightforward. 4 times 1 is 4. 5 times 2 is 10. 4/10 you can simplify a little bit by dividing both of the numbers by 2. And so then my final answer should be 2/5. Best possible simplified answer. Woohoo! All right, one more. Here we've got what type of fractions? Mixed numbers. And if you go back to the key ideas, you can't divide mixed numbers. Just like you can't multiply mixed numbers. You have to make them improper and then go through your division steps. So the first thing I'm going to do is make both of these improper. 6 times 3 is 18, plus 5 is 23. So this fraction can be written as 23/6. And the second fraction, 3 times 1 is 3, plus 2 is 5, so 5/3. Notice how I rewrote the division problem first. I didn't try to get too ahead of myself and flip it and everything all in one step. Don't do that. Write it out so that your brain can visualize and see what's happening so you don't make a silly mistake. Now we'll use our division rules, multiply by the reciprocal. So we're going to keep the first fraction the same, multiply, and then the reciprocal of 5/3 is 3/5. All right, so now a little bit of multiplication here. 23 times 3 is 69. 6 times 5 is 30. And now to simplify this, I'm going to make it into a mixed number. 30 can go into 69 twice with 9 left over. 2 and 9/30. Now, 9 and 30 both share a common factor, believe it or not, of 3. So you can divide everything here by 3 and simplify it just a bit more. 9 divided by 3 is 3. 30 divided by 3 is 10. 2 and 3/10. So this is your best possible answer. It's as simplified as it can be. And the only other thing I'm going to do today is go through one division word problem. I feel like it's important just to make sure you can see what makes a problem division. So in this question, it's saying 1 serving of tortilla soup is 1 2/3 cup. So if you go to a restaurant and they bring you out a bowl, the bowl has 1 cup and then 2/3 of a cup, 1 2/3 cups. That's a serving. A restaurant cook makes 50 cups, big pot of soup, and there's 50 cups of soup in that pot. The question is, in that big pot of soup, is there enough to serve 35 people? So what makes this a division problem? Well, here's what I'm thinking. If I have a big pot of soup, excuse my drawing, I'm not very good. Here's my big pot of soup, and it has 50 cups inside of it. I want to know how many bowls of soup are in that thing. How many 1 2/3 cup servings are in 50 cups? So in other words, I'm saying 50 cups divided by 1 2/3. And what I really want to know is, am I going to have 35 servings? Am I going to be able to serve 35 people? Does 50 cups of soup have at least 35 1 2/3 cup servings? So I'm going to divide it and see what I get. First step is I notice I have a mixed number, so I'm going to make it improper. So 50 divided by, and then 3 times 1 is 3 plus 2 is 5. And since it's division, I'm multiplying by the reciprocal. And 50 times 3 is 150. 1 times 5 is 5. And now, how many times can 5 go into 150? 5 can go into 150 30 times, exactly, with nothing left over. So what that tells me is 50 cups of soup, how many 1 2/3 servings can I divide that into? I can divide it into 30 servings. So back to the ultimate question, is there enough to serve 35 people? No. I'm 5 cups short. I would need 5, or not 5 cups, 5 servings short. I would need 5 more servings. So that's an example of a division word problem with fractions. Good luck practicing today. If you have questions, please reach out. Feel free. We're available. Otherwise, maybe join the Google Meet, and we'll see you virtually, maybe eventually. Thanks. Bye.